So our topic today is about the Reimann Sums, approximating areas under a curve. So before we proceed to our lesson, I will say that the rules for you to know. Okay, first one is to listen actively. You have to pay attention to the teacher or your classmate is speaking. Second is to participate, to share your ideas and answer the question confidently. The third one is to respect others during the discussion. Fourth is to show your work. So always try complete solutions, no shortcuts. And lastly, stay on the task. It is to focus on the lessons and put your mobile phones away. Okay? So our learning objectives, at the end of the lesson, the student should be able to approximate the area under a curve using the left, right, and midpoint Reimann sums. Second is to identify which method overestimates or underestimates the area. And last, to solve problems with at least 80% accuracy. Let's proceed to our lesson. So here is the 5-step process to find the Reimann sums of the left, right, and the midpoint. First, we have to find the delta x or the width of each subinterval. Second is the left Reimann sums. So when finding the left Reimann sums, we use the left endpoints as the height. The third one is when we find the right Reimann sums, we use the right endpoint as height. So the midpoint Reimann sum is the average sum. And lastly, we have to find the exact area or the definite integral. The exact area gives us the true for the exact area. So before we start our discussion, let me talk about the Reimann sums. So what is Reimann sums? Reimann sums is a method of approximating the total area under the curve on a given interval by dividing that interval into smaller equal subintervals, constructing a rectangle on each subinterval and then adding up the areas of all the rectangles. In simple terms, since we cannot always find the exact area under a curve just by looking at it, we approximate it using rectangles. The more closer our approximation gets to the actual area. There are different types, but today we will just focus on the left Reimann sums, the right Reimann sums, and the midpoint. So these are the formulas for finding the Reimann sums. Yeah. Okay, so let me give you an example. When we to find a, let's start. I will give you an example on how to find the right, left, and midpoint Reimann sums and the exact area using the definite integral. Can you read the problem, class? Go.
Find area bounded by y equals x cubed plus 1, 3 using n equals 2.
So we will start with this one class. We will find the delta x. B minus a over n. So our area is 1, 2, 3. So our b is 3 minus 1. And our n is 2. So our delta x will be 1. Find our delta x. So we'll start drawing the graph. Y is equal to x cubed and our n is 2. Our delta x is 1. So let's start with finding the left Reimann sum. So this is the formula. Take note of this class. Circle is 1. This will be our ground. 1, 2, 3. So let's now find the left Reimann sum. Wait, not. One. So this is our left. So this is our left Reimann sum, guys. Can you read?
Nice square units.
Okay, so let's now find our right Reimann sum. So this will be our graph. Ngayon is yeah, 7. Ito na yun. As per the so this is our right Reimann sum. Everyone read.
35 square units.
So lastly, we have to find the midpoint. So area is equals to what is our left Reimann sum? 9 plus how about the right Reimann? 9 plus 35? 44. So what is our midpoint?
22.
Okay.
I miss you.
Who wants to try to find the integration? Okay, Miss Ricardo. Left Reimann sum is underestimates our exact area, and our right Reimann sum overestimates the exact area, but our midpoint is the closest to our exact area. Okay, so here is the K rule of over and underestimate. So when it is an increasing function, the right sum overestimates and the midpoint is closest to the exact area. So when it is a decreasing function, the left sum overestimates, the right sum underestimates, and the midpoint is the closest to the area. So always, the midpoint sum is always the closest to the exact area among the three methods. So let's go with the Okay, let's generalize. Who wants to answer number one? Can I ask Miss Leon? In your own words, what is a Reimann sum? Reimann sum is the method of approximating the area under a curve by adding the areas of rectangles formed over equal subintervals. So what does thank you, Miss Leon. What does delta x represent and how do we find it? Mr. Douglas, can you answer?
X is the width of each semi-curve. We find it using x means B means C over A.
Okay. Over n. Thank you, Mr. Douglas. And how do the three types of Reimann sums differ? Okay, Miss Tintin.
So left sum uses left endpoints, right sum uses right endpoints, and midpoint sum uses the midpoint of each subinterval for the time.
Okay, that's correct. And last one, what is the connection between the Reimann sums and the definite integral? Who wants to answer? How about Miss Whitcomb?
So the definite integral is the exact area as it increases toward infinity. So the right Reimann sum gets closer to the exact value of the definite integral.
Okay, thank you, class. And now we will have the individual written quiz on one half sheet of paper. Solve the problem and follow all the 5 steps and show your work. Okay, we will start class. Are you done, class?
Yes,
May I ask Miss Sultan to show your solution on the board? Okay, thank you, Ms. Vitado. So, I see class. What do you observe in our... This is the exact area of... Ms. Vitado. So, what do you observe class? This is the exact area and this is our lab. Reimann Sums. So, what do you observe? This is degree. Alright. That is over the number. How about the right? Over. Okay. And this is the midpoint. Okay. All.